So today we're going to talk about wire bonding.
So we need to just talk about the concept of wedge bonding versus ball bonding, and it is a conceptual difference. You know, you're mainly doing wedge bonding because you can do it at ambient temperature. That's the #1 big advantage.
And because it's aluminum.
And you can do aluminum wire, right? And aluminum kind of came with the technology of wedge bonding. It kind of came at the same time, and aluminum wedge bonding is still probably 20% of the market. But the thing about aluminum wedge bonding is you can put bonds much closer together, and so density is a big issue with some customers that want to have like a 45 micron pitch, and you can't get that with ball bonding because of the size of the ball. And the other reason you'd use wedge bonding is the length of the wire is minimal compared to the ball and the big loop of that, and it's used for high frequency things where wire in the device ends up being like an antenna that you're trying to avoid the frequency problems. And then we talked about with wedge bonding you can do ribbon bonding, and then you can do bonds that are much larger wire that carry more current.
So what's ribbon bonding?
What is ribbon bonding?
Yeah.
It's just a ribbon of wire that's maybe in some cases like say 5 mils long and 1 mil thick, and it carries more current than a 1 mil round wire. So it's literally a ribbon, and it uses a different tool and a different feed mechanism, but it's mostly for high power.
So these four wires are for one pad, or they're for different pads?
4 wires.
I mean, you were mentioning that there are
Oh, it's for different applications.
Okay.
So some applications that, you know, you use a lot of high power, a high frequency, you'd use ribbon. But, you know, it's a different setup on the same wedge bonding concept.
It comes out like a piece of tape.
Yeah.
Yes, exactly. Yeah, it's like a ribbon, so it's long and thick.
Can these tools be retrofitted for ribbon?
Yes, the vertical feed that we've taken off of this machine is what you would use, and you would put a ribbon tool which has a hole like this that you feed it under, and then a flat foot. So yes, you can do ribbon with this, but you have to go back to the vertical feed. This machine, when I came in, had a vertical feed, and I've switched it to a standard angle feed, so it's easier to thread and easier to use.
Yeah.
Have you looked look in here and see the wires that we've bonded?
Yeah, compare that to the wires I did, or the bonds I did to you, for you.
With the aluminum like this, do you have to do any different coatings on your device that you're making to get the aluminum to bond better?
Right. All right.
No, actually,
I gotta go. The customer's giving me
same
a stick cut.
aluminum and or
All right,
gold uses the same pads that it bonds to or packages.
Yeah, I found the one I have, but
for wedge bonding as you do for ball bonding, but that's typical. I also talked yesterday that some of my customers are bonding gold wire at ambient temperature. It doesn't stick as well, it doesn't bond as well, but some of Some people have restrictions like that.
115 and 150.
And at first bond, the clamps open, the bond head retracts up and steps back. This distance here will be used later to create a tail length underneath the tool for the next bond. And then you chest over to where you want second bond. You depress the switch, it comes down, makes second bond, and then after second bond, the clamps pull back and tear the wire at the heel of the bond. And then when it goes back up, it falls forward, feeding the wire back underneath the tool, ready for the next bond. So we don't have to use a flame off, you're just using feed to feed underneath the foot. So this is an automatic bonder, but you can see the clamps behind the tool. And the other big difference between wedge bonding and ball bonding is that wedge bonding is one direction. It's not omnidirectional, it's unidirectional. So you have to bond from 6 o'clock to 12 o'clock. So you have to rotate the part and line up the second bond behind the first bond. Because the way the wire feeds is it feeds underneath the foot. And if you shift to one side or the other, you're not going to be underneath the foot any longer. So this is the other bonding cycle where the wire is underneath the foot, comes down and makes the bond, and then loops up and the clamps are open, comes down and makes second bond, ultrasonics is fired, clamps close, and then returns up to reset. This doesn't show you the clamp tearing action, but there are two types of clamp tearing. One is where you're actually using the clamps to tear, and the other is a motorized table that you use the table to tear. Where after second bond, the bond head rises, the table, motorized table moves, then the clamps close, then the motorized table moves and breaks.
Oh, that's fine.
This is especially used on the vertical feed because it's kind of hard to pull straight up on the wire and then feed it underneath the foot. So this is just a bonding wedge catalog, but they've got some great SEMs. This is a concave foot, so it captures the wire in the middle. This is that cross groove that shows you that is used to make the gold bonding. Okay.
Yeah, that's just.
Now there is a difference. There's similarities. These three machines are all wedge bonders. There's similarities and differences. These two are identical in their make and style. It's just that we have that one set up for aluminum, so it's not heated. This one's set up for gold, and it is heated. This has the cross groove tool in it. That's got the standard tool.
Oh, wow.
Then you go over to the other one, which is set up for aluminum, but it's the next generation. And there's a lot of similarities, but the main difference on that machine is that it has a small motor that moves the clamps, as opposed to this has two solenoids that do the clamp tear and feed. So probably the least understood part of this machine is this tear feed bracket. So that tear feed bracket, I'm sorry, let me get around you.
Sorry. I should have charged the battery.
That's kind of like my laptop. I sent it out to get a new battery and it came back with a bad battery.
So, you're talking about a pair of solenoids here?
Yes. That pair of solenoids is used to do the clamp tear stroke.
Yeah.
So when the first solenoid fires, after first bond, the clamps are opened and it steps back. This is going to later translate to the tail length.
Right.
Now, and then you go around, and this is where the second solenoid fires, and this is what provides the tear stroke. Now, when it returns to reset, it doesn't just fall first distance, it falls both distances. That's what leads, say this is the foot, it breaks the wire back here, but then feeds the wire completely underneath the tool. So in this machine, these two solenoids are what accomplishes that. Over there, you've got a little stepper motor that actually does that.
Okay.
Much more controllable and reliable. So it was one of the things that they added. So probably 80% of this machine was translated to that machine, except for that whole tear feed mechanism.
Very good.
So from the gun head down, the extractor was 72. What was that?
This was the.
All right.
Yep.
I have successfully made a bond, and
This one,
wire sticking out,
that's 0.
ready to make
That's
the
going to the gun
next
head
bond.
itself.
Remember, you're
To
bonding
look good
from
was good.
6 o'clock to 12 o'clock, so you have to line up your second bond behind you.
2.839.
Make one successful?
I don't know why you said from 6 to 12 is it's like 6.
6 o'clock here, 12 o'clock there. Because the way the wire is fed
Right.
underneath the foot.
That
It has
Yeah,
to go
please
this
do.
way.
Which I did not measure off the old chamber. Because I had to hold the extractor after out to
Bring
get
the
the
lights
to get to
indication
the
line
liner.
is the first bond will be.
That's correct.
Yeah, and the hall, yep, hall line.
You can move it with the mouse thing.
So
Okay. Okay.
this is the Chespin button at the top. So you press and hold. It'll come down and stop just
If I can
above the
get
work
to it,
surface.
that's the problem.
Press where?
Okay, you're going to hit that clamp
Different.
because I can see from this angle that the clamp is in the way.
Well, it's a different style chamber.
You see this
I think
clamp?
it's- I'm gonna check, make sure they're both the same. Oh, yeah.
Tools with the clamps are going to hit the way.
One of them that's screwed in recess, and the other one's screwed
Here.
That'd be safer.
from.
Here, why don't you bond out here?
Somewhere, okay, somewhere else, sure.
I'm sorry, let me
The screws that
center
Go
this.
here.
There you go, somewhere out there.
Okay. If I wanna do it right here.
So if you-
yeah, and then
Press and hold
which button?
the
This
top
one?
button.
Press and hold.
Yeah,
Yep.
that's the difference
Okay,
in
it comes
height.
down, and then
Are you over the gold surface?
yes.
Okay, now release it, it'll make first bond. Goes up to
Wow.
loop.
No.
Now chest straight back.
0.1 millimeter.
Pull the out.
So
I'm on top of another.
So press and
Okay.
hold.
Yeah.
Verify that you're where you want to be and release.
I was
Oh, it's
Did you
done.
successfully make a bond?
Yes, I did.
All right.
Wow.
okay. So that is this one's 0.1.
Wow, look at that.
It's a
Wow.
lot easier and a lot prettier, huh? Now
Yeah,
that it's
look at
tuned
that.
up.
Wow.
0.1 high.
What's the second
Now I can add.
This very good. This button here
I got the idea.
is a stitch button, and what it does is it continues to make first bonds
Bad boy.
until you release it, and then you make one final bond, and it terminates. So you can stitch bond without terminating the wire.
On the old one.
That's on wire bonding 102 class.
I'm getting there. So what I'm doing is I'm going to let it zero yet, like a little. And that way, it doesn't matter. I'm zeroing it.
think it actually did anything.
So this bonder has the solenoid rather than.
That's correct.
The motor, right? Which one has the motor?
The motor is on that machine.
Oh, they're exactly the same.
Okay. Cool.
So that's basically saying I'm good.
Neat.
Yes.
I understand the wire, aluminum wire, shelf life is what?
No more than 90 days, or no more than 6 months. They would say 90 days on some manufacturers, but 6 months.
And
The reason for that is the aluminum wire is doped with 1% silicon, and the doping, the silicon migrates out of the aluminum.
No worries.
what about gold?
Gold
All right, there you
is
go. Thanks.
only has, it's doped, but it's only doped with 3 to 5 parts per million of beryllium,
Okay.
and it doesn't migrate as the silicon does.
So I remember, it seems like one of the K&S guys told me at one time that there's a shelf life on the gold wire too.
Well, yes, they will tell you 1 year, but honestly, I actually had the
We're good.
president of one of the wire companies on the phone, and he says, honestly, that's just to release us from any responsibility beyond a year,
That's where our.
but stored properly, and that's the environment that you want. Stored properly, which is orientation, meaning that you've physically oriented it the right way, and you're keeping it in a dry environment. You
And not to
can,
mention, when we actually had our.
Gold wire
it was
doesn't go
1.5,
bad.
which does make sense. I think we were right.
I have a question. Sorry.
I don't know, can I? Ooh, what's this material here?
FR4?
No, I'm sorry, the metallization.
I don't really know. Think
Well, let's try.
Oh, there's. Well, that's. There's the old app.
Never hurts to try.
Yeah.
It would be cool is if you could do bumps of solder.
Yeah?
Is there solder wire you could bump with?
Not that I'm aware of.
That looks like their bag. That apartment doesn't look that far. I know.
is it room temperature?
Yes. You can see, because of the way it's, the fingers are on there, it's not flat. So, I mean, it's not really badly not flat, so I'm going to see what I can do. Hold on.
I don't know what the hell it's like. Oh, that's our star. Yeah.
I'm going to see if we can make some bonds.
The extractor star. Yep, that.
In general, can you
Throw this
bond
back in the bag.
like a solder?
Can I bond to solder?
Well, we measured it.
It's too soft.
We were 0.5, and these.
Solder wire, is there?
What's a solder?
That's
in general?
within spec.
Can I, I'm sorry.
Solder, like if you have print circuit board, right?
Right.
And you can you bond it to solder?
No, because the solder is like mud. You know, when it's
I can't believe I didn't.
just
I
be too soft.
straight pushed it in.
Yeah, he says
Okay.
Not for other reasons, just because it's soft.
Yes.
It's
It would push down into the solder, but there wouldn't be any intermetallic bonding going on. Okay, now there's two operations. One is the Chespin mode, where you press and hold and it stops and goes up to the loop, and then press and hold, stops at second search. The other mode is manual Z mode. On this machine, all you do is just move seamlessly between the two. On the 4500s, you have to turn on the manual Z switch on the keyboard. But in this case, I'm going to just do the manual Z mode operation and try to bond on this material. So now, instead of the machine speeding down to a search height, I'm controlling the head, and I control the travel. So now it's made first bond, and I'm slowly rising up from first bond, and I see it did not stick. It tried to, made a little bit of an impression, So what I'm going to do on second bond is I'm going to dial in some more parameters. So this is on 1.9 on power, 2 and 2 on force and time. I'm going to take this up to 3.0 and then 3.0 and 3.0. So I'm going to see if second bond might be better with those higher parameters. And it's stuck. So now what I'm going to do is I'm going to dial first bond also to 3, 3.
I'm going to make notes.
3.
That's why I'm recording this.
I kick myself, I ordered one, but I know what I did, I know what I did. I ordered an anode. Yes. I ordered the
Okay,
anode.
it made the impression, but when it come up, it lifted.
Not an attractor.
Same thing again.
Second bond, same thing.
Second bond also.
This has been bent from the get-go. Needless to say. So the good thing is we were able to verify your ticket shot.
Okay, so now
I don't know how.
I'm going to try more power.
Logically, honestly.
And this is what you're doing when you're dialing in a machine. You're just trying to watch what happens and see.
Well, if the tip was bent like that,
You have to make a schedule of bonding parameters.
We'll find out tomorrow.
That's a lot of parameters. I mean, you got 2 forces, you got 2 powers.
Yep.
So, you got some general guidelines for tuning that in, or?
So, yes, force is mostly a factor of wire, how hard or soft the wire is. So a given force works with a given hardness of wire. Power is just the amount of scrubbing action, and time is the duration of that scrubbing action. So time is power is the amplitude that it's scrubbing, and time is the duration of the scrub. And the most adjusted parameter is always power. The least adjusted parameter is time. Probably the most subtle of all parameters is time. And force, like I said, you typically use a given force with a given. Say it again.
Do you understand?
No. Nothing stuck. I can see where it scrubbed and made an action. I got one bond that actually stuck. And so what I'm now telling you is that I used enough power that I'm flattening this out. I may have to now decrease the force to be able to use more power. So it's a recipe. So now I'm backing off on the force so I can scrub a little bit more. Because if I use the same amount of force and go with more scrubbing, I'm going to break the wire, and it's not going to stick either. Okay, so I'm on 3s on force. I'm going to back it down to 2.5, and I'm going to take this up to 4.0. And so this is really just kind of creating a recipe. And you know, I say making wire bonds is like making cookies. You gotta have the right temperature and the right consistency, and it's just different recipes. Okay, still not sticky. Although when I bonded off, the second bond did stick.
Oh, second bond.
So now I'm just going to soak it with a lot more time. I'm going to give it like 6 on time. And see what happens.
Was it you or I that said?
So George, is that solder? A thin layer of solder on copper,
This is,
maybe?
I don't know. This is like kind of spring circuit board, but it's not spring circuit board. It's like protocol. So it's for purposely for some ICs, so you can just overflow it or solder it, and then it's got all the pins. For
Is it like
specific-
reflow?
reflow? Yeah. So I don't know what's the material. Solder.
Yeah, it's not bonding.
Usually it's copper and then tin,
Tin.
some type of solder.
Yes.
That's what they make.
I'm going to try scratching on it.
You said earlier before you got here that you want to match the hardness of your substrate in the wire as much as possible.
You want to match the force and the hardness of the wire. So a given hardness of wire will require a given hardness or force to make a deformation enough that you're holding these two materials together so that the scrubbing action is effective. I was explaining yesterday, it's kind of like wire bonding is like putting your hands together in the wintertime and rubbing. And my hands are warming up because of that scrubbing. Well, you're actually making those two materials into a semi-molten place and make an intermetallic bond by making that scrubbing action. But if a given amount of force works with a given amount of energy to scrub, but if I double the force, it makes the scrubbing inaccurate and inefficient.
Right.
So there's a force profile that works with a given scrubbing action, but if you go too far on force, you're diminishing the scrubbing. You're dampening it. Okay, now I've scratched it up pretty good, and now I'm not getting anything. And I'm pretty well flattening out the wire to nothing. It wants to stick, and then just naturally when I lift up high enough, it pops loose. So the answer is this material is not bondable with this wire.
This is aluminum.
Yeah, it's aluminum wire. And it's pretty hard material, I can tell you.
So it's not because of the softness. It's because something else.
It's the metallization period. Want to take it?
Are there any other types of wire other than aluminum gold?
Yeah. That's where we were talking about copper ball bonding.
Oh, right, yeah.
Can we try gold? Like a,
Yeah, I know that gloves. This
so
is
do you think gold?
Sure.
I'm
I
not gonna
just
use it ever
let me
again.
get this
Once
set up
installed, it's like-
for these guys to do some wire bonding.
This is your 7
And
left.
actually, I need to teach this young man how to set up the. We're going to set up the work holder height. Have you set up the work holder height so you can go through that.
Oh, yeah, that's important.
Has a niche market of, high power where you need a lot of volume to carry current.
Right.
It's also preferred for high frequency because you can control the length of the bond as opposed to a ball bond that has a lot more wire and acts more like an antenna. So, but ribbon bonding is still a niche market. Round wire bonding, both for wedge bonding and ball bonding, are still the standard bonding procedure. There's also flip chipping, where you're actually putting bumps down and turning it over, but that was at one time supposed to replace all wire bonding, and the number of wire bonds bonded worldwide just continued to increase and has since day one.
So do you know anything about flip chip? And
I don't do much flip chip. I have some customers that do. You can use not the wedge bonder, you can use a ball bonder to put down.
yeah.
bump bonds.
Right.
Solder bumps are the other route to go.
Right.
But you know, these machines have a ball bumping and a coining function in them.
Yeah, we played around with coining a little bit. Bumping. Putting down the, look like Hershey's Kisses.
Yeah. Yeah. Exactly. That's the term I use. It's a Hershey Kiss, and then you come around with a coining tool and flatten them all down to a given height so that the planarity is flat.